One of the things that I think about a lot is the web. You know, what it is, how to use it well, how it got to be the way it is, how we're going to make it better. Given the way that it came about, making it better is a surprisingly hard thing to do. For years, we've been trying to move it in one direction or another. I'm going to propose to you today that the direction in which we attempt to move it be forward. Okay, but first I'm going to take a running start at this and introduce you to this guy. This is Gordon Moore. He went on to become one of the founders of Intel, eventually ran the place. Really bright guy. In 1965, he wrote an article in Electronics magazine in which he observed that the bang for the buck in semiconductor devices seemed to double every year or two. And he speculated in this article that he expected that trend to go on for at least another 10 years. He couldn't see any reason why it wouldn't. And it's gone on a whole lot longer than that. It's been going on for over 40 years. So we've seen a factor increase of 1 million, which is a huge increase. And that's what's made possible pretty much everything that we do now. Moore's law became a self-fulfilling prophecy. It wasn't really a law, it was just an observation, but it's become a principal planning tool for the electronics industry. It can't hold forever, and Moore himself many times has said it's not going to last forever, but we still haven't seen any sign of it slowing down. So it's an amazing effect. I feel there are amazingly brilliant engineers and scientists at Intel and AMD and other places who keep this thing running, and they don't get nearly enough credit for what they do, because they do these amazingly wonderful things in order to produce the next generation, and everybody goes, well, yeah, we knew you were going to do that. I mean, Moore said it's right there, you know. And the Moore effect applies not just to processors, but also to memory, disk drives, network bandwidth, pretty much everything electronics is affected by Moore's law except for software. And that's because software is not subject to Moore's law, software is subject to Murphy's law. We're getting a little clipping on that. Oh, that's too bad. So software productivity improves at a much slower rate than electronic devices do, doubling every 10 or 20 years rather than every 2 years, as we see in semiconductors. Now, that's not a bad rate of increase. Any other industry would be really happy to have that. You know, if manufacturing or agriculture could have similar improvements in efficiency, that would be huge. They don't get that. Software does. It's just not as impressive as what we see in electronics. So leap forwards in software productivity come much less often, much slower. The first one was plug boards. That was the first form of practical software in which you had a plug board and you'd take wires and stick them in the holes, and that would allow you to reconfigure a machine. So you could produce a custom machine without having to build a machine. The next step forward was machine codes, in which you would have numbers which would represent the connections within the machine. That was much easier than manipulating the plugs. The next step forward was a symbolic assembly language, in which you'd be writing using mnemonics and symbols rather than memorizing numbers. Huge leap forward. The next step forward was high-level languages. When this step was being taken, it was called automatic programming. The idea was, we'll let the computer write the programs for us. All we have to do is write the specification of it. So if we write the equations and then let the computer write the program, then it'll be much easier. And it turned out it was much easier, except that writing the specifications really is writing the programs. And so we didn't get all the way there. The next step forward was structured programming, in which we put some constraints on the way the programming language worked in order to better manage complexity. It turns out complexity is the really hard thing about programming. And then the last step forward was object-oriented programming, which is the most recent step. The next step is long overdue. We should have been there by now, and we haven't. We're still in the object-oriented stage. And looking back at object orientation, the major milestones were first, 1967 saw Simula. Simula was the first object-oriented programming language. Came out of Norway. 1980 was the first commercial implementation of an object-oriented language, which was Smalltalk 80. And then in 1995, Java came out, and Java became the mainstream object-oriented language. At that point, it was not just the new way of doing it, it was the way everything was done. And there should be all of that happened some years ago. We should be up to the rest of it. I think the next step forward, the next leap, is going to be the realization of the dream of building software systems like we build stuff out of Lego, where I can have components that come from different sources, I can put them together, and have interesting behavior come as a result of that. The components will be able to communicate with each other and cooperate with each other. And it turns out we're doing that. We call it mashups. And some of the first work on mashups was done here at Yahoo. And it's really good stuff. And what we've realized here is something that people have been working on for years. And it's been called software ICs, and it was called Corba for a while. There have been a lot of attempts at doing this, but it's only in mashups that we've actually gotten this stuff right. And I think one of the reasons why mashups are working now is that JavaScript, for all of its problems, is actually the right language for doing this stuff. It has the right balance of dynamism and expressive power that it's allowing us to mash up. It seems to be much better suited than the conventional object-oriented languages for doing this stuff. Unfortunately, the web is under attack. And this is a consequence of the designers of the web having not considered the security implications of their invention. And so they inflicted the World Wide Web on the whole world, and we're experiencing the consequences of that. The biggest problem with the browser is its security model. The browser security model has always been inadequate, and it is especially inadequate for dealing with the needs of AJAX applications. The browser simply wasn't designed to do the things we're asking of it. And the weaknesses of the browser are now blocking innovation. The browser is not a safe programming environment. It's an inherently insecure programming environment, and there are terrible consequences of that. One of which is the XSS attack, which is a consequence of a malicious party somehow getting some script onto your page. And that could come in the form of user-generated content, or it could come in the form of paid advertising. There are lots of ways to get the bad stuff on the page. Once it gets on there, bad things can happen. An attacker can request additional scripts from any server in the world. So they only need to get that much of a foothold in order to then load all their siege software onto the machine and do whatever they want. The hacker can then make requests of your server, and your server cannot tell that the request is coming from the evil script and not from your script. If your server allows access to the database by accepting SQL from the network, then you've given access to your database to the attackers on the network. If you have an SSL connection, a secure connection, the attacker gets access to that session. If you have passwords in place, he gets access to that stuff as well. The attacker can read the document. So the attacker can see everything that the user can see. In fact, he can see things the user can't see, because he can also see the scripts, he can see the hidden fields, he can even see the comments. So everything that you've sent to the page, you've sent to the attacker. Now, one mitigation to those problems is if the user tries to do anything important, we'll ask the user for the password. That way, the attacker can't pretend to be the user. Except that the attacker has access to the display as well. So they can put up anything they want, including asking the user for their password or any other confidential information. The browsers now have a lot of security chrome on them to prevent phishing and other sorts of things. Most people aren't paying enough attention to that stuff yet, but if they are in this attack, it won't matter, because the page believes that the script is legit and will tell the user, this is Yahoo, tell them everything you would tell Yahoo. Then the attacker can send all of the information it's collected to any server in the world without restriction. In most computer systems, read access is easy to get, and write access is hard to get. On the web, it's the opposite. So the same origin policy prevents us being able to read data from any site, but we can send data to every site. So that's all really bad. The browser does not prevent any of these things, and that's why they happen. And the consequences of a successful attack are quite horrible. There can be harm to customers, there can be a loss of trust, there can be legal liabilities, and there could even potentially be criminal liabilities. And this is all happening because of misdesign of the browser. These vulnerabilities are required by web standards. There are bugs in all the browsers, and those bugs do lead to security problems, but I'm not talking about bugs. I'm talking about behaviors which are required by all of the affected standards. W3C and ECMA require that these holes be present in order to be standard compliant. So there's a prevailing mythology within the web developer community, and the gods gave us web standards, and deviation from the web standards is the source of all evil. This turns out not to be the case. I think the web standards are themselves the source of a lot of the evil that we're dealing with. And I find a lot of developers get this codependent relationship with the standards. CSS isn't bad. You just don't understand it like I do. It hurts me, but it doesn't mean to. It's my fault. I make mistakes. I don't know why I make mistakes, but it does. And if I didn't have CSS, what would happen to my pages? So the web was once a driver of innovation, caused huge changes in the world. The web is now the obstacle of innovation. We cannot move forward because the web simply isn't strong enough to take us forward. And web development requires mastery of the workaround. You can't do anything in a straightforward way and expect it to work. And that's really unfortunate. It's hugely counterproductive. It's standing in the way of everything we're trying to accomplish. And worst of all, you can't work around security. Security isn't accomplished by tricks and hacks. It's a fundamental thing, and the fundamentals in the browser are really weak. So here's a principle. If there is script from 2 or more sources, the application is not secure. And that's exactly what we're trying to do in a mashup. We're trying to take script from 2 or more sources and have them work together. So a mashup is a self-inflicted XSS attack. And in order to go forward, we need to find a way to make mashups work without exposing the components and us and our users and everybody to harm. So how did this happen? Let me take you back to when computers were still a fairly new thing. You had a computer, and you would run in the computer some software, and the computer had no understanding of whose interest it was represented by the program it was running. It would just run it. And generally, the interests of the owner of the machine were equivalent to the interests of the program. But that changed pretty quickly when computers started having to run more than one job at the same time, because a badly written program could crash the computer, and that would cause at least big operational delays, and that became expensive. So user mode was invented. So the computer now represents 2 interests. There's a user program, and there's the system program. And the user program cannot do anything which will affect the integrity of the system program. And that was an important innovation. In the time-sharing era, a mainframe would run programs from several users at the same time. And so it needed to keep track of all of those separate interests. So each of the users would be isolated within the same machine. Toward the end of the time-sharing era, some of these users wanted to figure out how they could cooperate. Either they wanted to play together or they wanted to collaborate. And the system didn't provide an effective way for them to do that. But had the time-sharing era continued, perhaps that would have been figured out. But then the PC era happened, and we start over. So everything that we learned about how to write operating systems was forgotten. We started over with CP/M and MS-DOS and the Mac OS and Windows, which again assumed that everything ran with the same interest. And that made it easy for floppy-borne viruses to propagate. Since the computer couldn't distinguish the interests of a script on a floppy from the owner of the machine, anything the owner could do, the script could do. And viruses happened. When you hooked PCs up to the network, then you got network-borne viruses. And that's still a problem in PC operating systems. We're still not at the point where they can fully enforce the interests of a user versus the interests of a program. Things get better, actually, when we go to the web browser. The browser is able to distinguish multiple interests. The browser represents its own interest, it represents the user, and to a limited extent, it can represent sites. But within a page, it can't. So within a page, all of these interests are confused. So an ad or a widget or an AJAX library, they all get exactly the same rights as the site's own scripts. And that basic confusion is the enabling technology which makes XSS attacks possible. And that's why mashups don't work today. JavaScript as a programming language came really close to getting this right. Unfortunately, it's built around a global object. And that global object is where the XSS attack actually happens. I think it can be repaired. And in being repaired, JavaScript could become an object capability language, which would allow us to safely mash up. So what do I mean by an object capability language? Basically, it's taking object-oriented programming and applying it to security. So here, A is an object. An object is a unit that has some state and behavior. Object A has a reference to object B, and that will allow it to communicate to object B because it has that reference. And object B provides an interface to A. So A isn't allowed to get at B's internal structure. B provides a nice interface, and that becomes the contract through which A and B can communicate. Here, object A does not have a reference to object C, so A cannot communicate with object C. It can only communicate with objects that it has references to. An object capability system is produced by constraining the ways in which object references are obtained. A reference cannot be obtained simply by knowing the name of a global variable or a public class. And there are exactly three ways by which to obtain a reference: by creation, by construction, and by introduction. So by creation, if a function makes an object, then it should get a reference to that object. It has to, or it doesn't make sense. By construction, an object may be endowed by its constructor with certain built-in references. And third, by introduction. Here, A has references to B and C, but B and C do not have references to each other, but A decides that it wants B to be able to interact with C. So it does an introduction. It does that by calling B, passing a reference to C. So when that reference gets delivered, B now has the ability to communicate with C. It now has the capability of communicating. That's why this is called capability security. There's really nothing new here. I mean, this is the way object-oriented systems have always worked. The innovation is on restricting the way in which references are obtained. And by that restriction, suddenly every object has a firewall around it. And we can make very good decisions about how we grant capabilities to other objects, and the system becomes much more reliable. This is the basic mechanism that we need in order to mash up. So if references can only be obtained by creation, construction, or introduction, then you may have a safe system. And if references can be obtained in any other way, you do not have a safe system. And that is the state of the art today. So good object capability design is good object-oriented design. And we found in reviewing a lot of designs, in cases where you have a difficult design trade-off in an object-oriented domain, you could write a class this way or that way. If you think about it in terms of capability design, that always answers that question correctly. So it's going to take a long time to get an object capability system into a critical mass of browsers. So in the near term, there are some other things we can consider. There are safe JavaScript subsets that can offer some degree of safety right now. There's Kaha and Kahita coming out of Google. There's AdSafe, which is a project I'm working on. It turns out the most effective way to make JavaScript a better language is to make it a smaller language. And we can actually remove from the language the things that make it insecure. And by removing the sources of insecurity, we're left with a secure language. These systems, I think, are at best interim solutions. I'm not confident that they're going to last to the end of time, but I think they do give us a couple of years in which we can start doing useful stuff while we're waiting for more permanent solutions to come online. We're also starting to see some progress being made in VAT architecture, where a VAT is a leak-proof computing vessel. Some of the stuff that Google's been doing with Gears and now in Chrome, where they isolate JavaScript processes and allow communication between them, I think that's the right direction, and we should definitely be pursuing a lot of that stuff. So I see three possible solutions for how we fix the browser and allow us to take the next step forward with mashing up. And they all happen in different time frames, and I recommend that we pursue all of them simultaneously. So the first is to start working with the JavaScript subsets. I think the stuff with Kaha and Kahita is really good stuff, and we should definitely be pursuing that. Second, we should be working with the VATs and trying to get the VATs installed into the browser. We can start making action on that stuff now. Getting people to accept any kind of download or plugin is really difficult, and so that's going to be a hard road. But if the whole industry gets behind it, there's a chance we might be able to pull that off. Then in the more distant time frame, we need to fix the browser. We need to replace the principal programming language with a secure language. We need to replace the DOM with a secure API, probably something modeled after the Ajax libraries, stuff happening in YUI3 and jQuery are a much better API than what the DOM provides natively, and I think ultimately that needs to be standard equipment in the browsers. And I think we should be doing them all. So how do we move forward? Because the web's sort of stuck. The way we did it before was with a browser war. Back in the 90s, back in the 20th century, there was a dispute between Netscape and Microsoft, and they attacked each other in the market through their browsers. And one of the consequences of that was we saw really furious innovation. Both companies were putting a lot of stuff into the web really quickly. We never saw that kind of innovation before or since. But they also put a lot of bugs into the network. They were pumping bugs at a furious rate. And it took years for those bugs to flush out. When you're in that kind of a development cycle, bugs don't get fixed because you can't guarantee that every one of your customers accepts the fix. So from the point of view of a web developer, the bug list is constantly growing, never decreasing. And applications which worked this month will fail next month, and you can't predict when and how they're going to fail. It was a really awful time for web developers. And as a consequence of that, people who have lived through it vowed never again. We cannot tolerate that kind of reckless behavior on the part of any browser maker or any vendor. That we need to come up with a more peaceful and more civilized way of determining how this stuff goes forward. And that way was standards. The openness of the web standards is hugely attractive. Unfortunately, the standards are bad. They're the source of all of our problems. And so in order to change the web, we must change the standards. But that turns out to be really difficult. A revision to a standard is an act of violence, in the same way that surgery is an act of violence. It causes pain, it causes injury, inconvenience. In extreme cases, it causes death. So it should only be considered in cases where the risks balance out or the benefit is clear. Changing a standard just to be changing it or because it's time to change it is as reckless as unnecessary surgery. In particular for the web, since web users cannot opt out of what changes. In most standards, a user of the standard can decide whether or not they want to accept it or work with another one. In the web, there's no way to opt out. You're either in the web or you're not. And so the consequences to everybody who uses the web are big. And that's not usually adequately considered in the standards making process. So not only are the web standards broken, the web standards process is broken. We see a lot of design by committee, and that results in a lot of pork barrel standards making, where the standards tend to get really, really big, really, really bloated. And my contention is that good standards do not come from such a process. In fact, we need the opposite. Minimalism should be highly valued in standards, because the less we have to agree on in order to interoperate, the more likely we're going to get it right. And having specifications which are too big for anybody to read, let alone for everybody to understand, is not a good way forward. And committees are just not good at doing minimalism. That's not what committees are for. So in my view, the standards process is entertaining way too much speculative technology. We got lucky in the case of ECMAScript. ECMAScript was being pushed in a direction which would have at least doubled the complexity of the language without at the same time giving us any capabilities that we don't have now. So there's no program that we could write with the new language compared to the old one, but we'd buy a lot of complexity. In my view, that was a really bad trade-off. As much as you might complain about the way JavaScript came together, and nobody complains about it better than I do, that was not the way to fix it. And fortunately, we won. That project collapsed under the weight of its own complexity, and we're now pursuing a much more minimal approach, which I think is the proper way to go forward with this language. But not all other standards have gone that way. In particular, CSS3 and HTML5, I think, are in the weeds. So the ES4 proposal, as it was called, contained a whole lot of pork, lacked a credible value proposition. The design process went years over schedule. It started in 2000, and it followed through to this year when it collapsed. That design was ultimately abandoned. Instead, we have a modest ES 3.1 proposal, which will actually make some important fixes to the language and put it on a platform which will allow us to evolve it in a more reasonable way going forward. So one of the problems that happened at ECMA was that the standards process was not risk averse. A standards body should be extremely reluctant to make any change and should only make the change when the need is compelling. Because once an error gets into the standard, it can be virtually impossible to get it out. In fact, the biggest obstacle we have in trying to fix JavaScript now is that for every design error that was put in the language, there's some clever one of you out there who's figured out how to use it. And so we're trying to minimize the harm that we do by fixing the language. And it turns out there are a lot of bad programs that depend on the language being broken in the way it is. The problem with the bad features isn't that they're useless. The problem is that they're occasionally useful. And that makes it really hard to move forward. So the dilemma we're looking at is good standards happen slowly, and our need is urgent. The web is broken now. We've got huge security concerns right now, and we can't go forward, and we can't afford to wait. The web standards are currently frustrating progress and endangering everybody who uses the web. And it's ironic because web time used to mean really fast. Back when Netscape was running things, they used to boast about, yeah, we're living in web time, like they were in the Matrix. And things were just happening at a furious rate, and they were. They didn't have time to think. They were shipping faster than the speed of thought. And then it all stopped, because that turned out not to be a smart thing to do and was not a sustainable model. So as a consequence, the last revision to ECMAScript 3, or to ECMAScript, was the third edition that came out in 1999. The last revision to HTML came out in 1999. We have been stuck since then. And how do we go forward again? So I think what we need to do is go back to the browser war. Now, you might be thinking I'm flip-flopping. And yeah, and I am. And it's because the only thing worse than where we were is where we are. So at least in a browser war, innovation happens. And there's a way to try out a lot of stuff and get it to market and let the market decide what the way forward is. Because having this stuff being driven by a standards body certainly doesn't work. Maybe having things driven by by browser makers makes more sense. I don't know, but It's got to make more sense than what we're doing. So I say bring it on. Time for a browser war. I think it turns out that a browser war is a good thing. It introduces a lot of chaos into the marketplace, and most of the cost of that chaos is going to be borne by you. Your lives will become much more difficult in a browser war because stuff that worked today is not necessarily going to work tomorrow. And so keeping up with the churn of the browsers is going to be really, really difficult and painful and expensive. But generally the market does a better job than self-selected committees as to what we really need and what's required to go forward. But this still is problematic. One of the things the marketplace has to do a better job of is punishing browser makers who make really bad stuff. And I'm not accusing anybody of making bad stuff, but looking at past performance, it's possible if the competition gets too heated. And so we will need to push back. One of the things that we do at Yahoo that I really like is we've got the graded browser support program. We determined that it's really too expensive to give full support at an AJAX level to every browser that's ever been made, particularly the really crappy ones or even the sort of old ones. And so we've got a list of the ones that we want to give full support to, and the other ones get the degraded experience, but they can still get the data and the service, and that's good. I think we should be applying that to enforce the quality of the browsers themselves. So if we see a browser maker who's getting too full of himself or getting out of line or shipping crap, we'll warn them, your users are going to get the degraded experience unless you fix this stuff. You really need to be attentive to this. And I think we should call on the rest of the web community outside of Yahoo to follow with us. I'm not saying that we dictate what the standards need to be, but we need to at least dictate what the level of quality has to be. If someone wants to get fully supported, they need to justify it. They need to be worth it. One of the really bad practices we saw back in the first browser war was sites which were dedicated to a particular brand of browser. And if anybody came to their site with a different browser, they were given nothing except a page that said you need to get a different browser. If you look at the user agent string on IE, it identifies itself as Mozilla. And the reason they do that is because there are still sites out in the world which will refuse to send a page if they identify themselves as Internet Explorer. They tried doing that in Internet Explorer 1.0. In 1.5, they called themselves Mozilla. They've been doing it ever since. So as web developers, we need to be really vigilant against that kind of bad practice. We need to be forgiving of everybody who comes to our site, but only give the premium experience to the browsers that have been proven good enough to receive it, but not to send anybody away and not to be playing favorites with any particular brand. That I think, seriously works against us and our users. So where should innovation be happening? It should be happening in research laboratories, in startups, and in forward-looking companies, say like this one. It should not be happening at standards bodies. I think that's the wrong place for it. And I think standards should instead be a conservative process that documents the best of what's been proven to be useful. A standard which is doing invention or is speculative, I think, is inevitably going to be a bad standard. Instead, the drafting of standards is a difficult, serious business. I mean, writing how things should work in detail is really hard and really valuable. And that is the thing that standards bodies should be focused on and not anything else. So standards should not be inventions. Standards should be agreements. Once we've figured out what actually works, that's the thing that we all agree should be standardized. Standards should work. And we should also be looking past the web. The web is just one in a long series of experiments in application delivery. And there's nothing about the web which suggests to me that this should be the last one. There have got to be better ideas out there that go on. We've seen a lot of vendors are out there trying to do the next one. We see Adobe and Microsoft and Sun all trying to do the thing that's going to replace the web. none of those systems look to me to be good enough to replace the web, even though they're clearly significantly better in some ways. I don't think any of them are going to click. For one thing, none of them have a better security model than the web, as awful as the web is. And, lacking that, I don't see how it makes sense for them to replace it. But eventually, something's going to be replacing it, and we should start thinking now about what that's going to be. What about the web experience worked? What about it didn't work? How can that inform how the future ought to be? And in the meantime, I'll be seeing all of you in the trenches. Thank you.